G'day, and again we'll be looking a little bit more at some pulmonary physiology, and what we're looking at is the diffusion of oxygen across from the alveoli into the capillary, across into the capillary, into the plasma, and then moving across to bind to hemoglobin in the red blood cell, and sort of the kinetics of this. So really what we have to do is we look at two sort of diagrams. Here's our alveoli, and then always we'll do the capillary here in red, and here's a red blood cell with its hemoglobin here in the capillary passing by. So also at the same time, what we'll do is we'll look and see what's happening here with your PO2 hemoglobin saturation curve. So of course here's 100% saturation. Here's a PO2 of 100, and we're currently here at a PO2 of approximately 40 as the blood is entering the pulmonary capillary from the pulmonary artery. Of course, this blood is deoxygenated, it's had the oxygen taken out, and so what we're saying is we've got approximately 75% hemoglobin saturation. So we know, or we hopefully remember, that as we enter the PO2 of the deoxygenated blood from the pulmonary capillary, as it enters the pulmonary capillary, is about 40 millimeters of mercury, whereas the PO2 of the alveoli is, we're saying, approximately 100 millimeters of mercury. So therefore, the partial pressure gradient, or the pressure gradient, is favouring the movement of the oxygen into the capillary. Now remember, the PO2 value here is the value of the oxygen dissolved in the blood, in the plasma. It has nothing to do with the amount bound to the hemoglobin here. Alright, the PO2 is the amount that is dissolved. So what happens? Well, we know that when the blood gets into the pulmonary capillary, we've got this pressure gradient, so oxygen now comes in and enters the capillary. Now as the oxygen enters the capillary, the PO2 increases and it rises slightly. Why? Because this oxygen dissolves, and it dissolves here in the plasma. So what does this do? Well, when the oxygen dissolves in the plasma, the PO2 rises. So we go to this point here, and you can see as we move up, it means that more hemoglobin is going to be bound to oxygen. So how does that work? Well, the oxygen that gets dissolved quickly moves into the red blood cells and binds to the hemoglobin molecules found within. So as the oxygen leaves here, it means actually that the partial pressure will start to go down or remain stable, and so more oxygen will come in. The partial pressure will slightly rise and more oxygen will move into bound, because we know as the oxygen levels get higher, we move to here and we have more oxygen bound to hemoglobin. So this process continues, and we're looking at microseconds here. The oxygen moves across, slight rise in partial pressure of oxygen. That oxygen therefore means that there's more affinity, so there's more hemoglobin saturation, so that oxygen moves from here into here. So first things first, the oxygen enters the plasma, increases the PO2, and it's this increase in PO2 of the plasma which means that the oxygen will then move and bind to more hemoglobin. Now this will continue until the PO2 reaches a value of 100, when it becomes equivalent to that of the alveoli. And we know at this stage we basically have close to 100% or full saturation of all our hemoglobin molecules. So therefore, this process normally will take about 250 milliseconds to move across, and of course we've got blood consistently moving through here to get reoxygenated. So to move from a partial pressure of your arterial blood to move from 40 to 100 takes approximately 250 milliseconds. So what would happen to the content of oxygen in our blood if, for example, instead of a PO2 of 100, let's breathe in some 100% oxygen or something like that. Let's have a PO2 of 700. How much would that increase the oxygen carrying capacity of our blood? Well, it's not really going to do much, is it? And the reason why this is because at a PO2 of 100, which is our normal value, you can see here we've already 100%, we've saturated all our hemoglobin. So no more of this oxygen is going to be able to leave the plasma and bind to the hemoglobin. Instead, it will be dissolved. And we know that oxygen has a very low solubility in your plasma, so therefore additional PO2 in someone who is fit and healthy is not going to massively increase the oxygen carrying capacity of your blood, because it'll only be dissolved. No more of that will be loaded. Okay.